and we'll see a practical code examples. How can we implement this actually? Okay, during peak times when there is a very popular event or popular show like let's say Coldplay show or India Pakistan Cricket World Cup match, right? The ticketing platforms experience a heavy load of concurrent user requests, right? So now let's just see a Redis implementation of our Leaky Bucket. Okay. Hey everyone, welcome back to the channel. So in today's video, we are going to discuss the system design behind designing a ticketing platform like BookMyShow or Paytm Insider, right? Which handles, during peak times when there is a very popular event or popular show like let's say Coldplay show or India Pakistan Cricket World Cup match, right? The ticketing platforms experience a heavy load of concurrent user requests, right? And today we are going to discuss how during those peak times, this kind of ticketing platforms handles those loads and ensures smooth ticket booking. Although it has not been the case in BookMyShow since last few events where it has failed to, in some manner to allocate tickets for its users. So, but still we'll try to dive into the entire end-to-end system design. Okay, and we'll discuss all the underlying concepts that work together to make it possible for a ticketing platform like BookMyShow. Okay, so if you see, there are a lot of concepts, system design concepts that goes into play when you want to design something like this, like load balancing, rate limiting, database design, scalability, caching, locking, high availability. A lot of concepts are involved, right? They work together. So I'll discuss about all these things on a broader sense, but my main focus today will be discussing about rate limiting and event queues. Okay, like how rate limiting works in case of designing a ticketing platform like this, and how it enables a server without getting overwhelmed or overloaded to process request in an efficient and seamless manner. So as you can see, I have used this image from Geeks for Geeks, and here there is a leaky bucket. Now, what does a leaky bucket mean? It is a kind of rate limiting algorithm, right? Limiting, by definition, it means you want to control the rate at which request reaches a server, right? I mean the rate at which a server can process, you want to limit that, okay, based on the capacity of the server. If a server capacity is to handle, let's say, 10 or 20 requests per second, then even if there are 1,000 requests coming from the user, you want to have some kind of tool or some kind of algorithm playing here in the middle, which will control the inflow of request to the server. So that's what Leaky Bucket does. Leaky Bucket is one of the rate limiting algorithm. There are other algorithms also for rate limiting, like token bucketing, and a lot of algorithms are there. I don't remember the one of the other algorithm name. But today we're going to discuss about Leaky Bucket, and we'll see a practical code examples. How can we implement this actually? Okay, using Node.js and Redis and Kafka, etc. So stay tuned with me. So first, let's understand what does Leaky Bucket do. As you can see, we have a bucket here. Okay, we pour water in the bucket, and the bucket has a small hole below it, right? So you are continuously pouring water inside the bucket, but below the bucket, the water droplets drop one by one. Okay, in a controlled manner, right? So even if you are bursting the bucket with a flow of water, large flow of water, there is a fixed output or fixed number of droplets that comes in a fixed manner, right? What are these water droplets? These water droplets are the request. Okay, the user request that reaches the server. So now what happens if the bucket is full? Let's say output is slower, right, than the input. Then obviously the bucket will become full. As soon as the bucket is full, what happens? The excess water goes out of the bucket, right? So that means the excess water is discarded from the bucket. So this exact algorithm, okay, of leaky bucket is implemented to achieve something like rate limiting. So in rate limiting using leaky bucket algorithm, what we'll do, we'll have a queue. Okay, let's say we'll have a queue. Okay, which will hold the request first. Okay, we can have multiple requests that is coming from multiple users, right? It will hold the request first. Okay, and it will have a fixed capacity that as you can see, this bucket has a fixed capacity, right, to hold some water. So let's say this queue has a fixed capacity of 4. So and we'll have servers, okay, which will have its own capacity at which it can process the request. All right. So at a given point of time, or let's say the server has capacity to process 2 requests at a time or 4 requests at a time, as in let's say 4 requests per second or 2 requests per second. So if excess requests are coming, let's say suddenly the load on your app increased, right? So a lot of requests will be coming. Let's say 10 or 20 of requests are coming, but this queue has only capacity to hold 4 requests, right? And this server has capacity to process, let's say, 4 requests per second, right? So where the other 6 requests will go? So those 6 requests are nothing but this excess water, right? Which will overflow from the bucket or overflow from the queue. That means in simple terms, we are going to discard those requests and we'll send some message to the user like, too many requests or the server is busy or try after some time, and will notify the user, okay, about the same. So that's what the overall leaky bucket algorithm is about when implementing rate limiting using leaky bucket. So this queue is nothing but our bucket, okay, and these requests are the water droplets. Now I'm going to show you code examples how you can implement this leaky bucket algorithm using first, let's say, in a simple Node.js Express server. So we have Express rate limit package actually. So it will implement a rate limiter for your application, which is directly coupled with your Express.js application. Okay. So obviously in production you want to use this kind of tightly coupled rate limiters, but for your reference, let's just see these ones. Okay. So if you see, you have defined a rate limiter, how many requests it can manage per second. We have defined that also, max is equal to 100. And in case number of requests exceeds 100, right, at a given point of time, what we're going to send, we're going to send too many requests, please try again later. Okay. So this is a simple module given by Express rate limit package, which you can actually use to implement a directly coupled rate limiter. But in production, you will use something like a message queue like Kafka, or if you want, you can use Redis even. Okay, you can use Redis list to create a queue. Okay, which will queue the request, incoming request, and process them in a asynchronous manner, in an independent manner. So now let's just see a Redis implementation of our leaky bucket. Okay, for this case, I am using IO Redis package, and here what we have done, we have a function called add to queue, and we have a queue key called ticket queue. Okay, so this is basically a name of the list or name of the queue that we are creating. Okay, so that we can reference it later and get the request from this queue later. Okay, so what does this add to queue function does? It does nothing but it does a rpush. Okay, redis.rpush. That means inside this ticket queue is a queue, basically it's a list. Let's say in the list side, in the right hand side, you are pushing the request ID. Okay, you are pushing the request in the list. Then we have a function called fetch from queue, which does nothing but it does a lpop, right? I mean, how does a queue work? You have a queue, requests are being pushed from the right one by one, and you want to pop from the left. So basically fast in fast out manner. In a FIFO manner, you want to process extract the request and process them, right? So this is what this fetch from queue function does. From Redis, we are using lpop, from basically pop from the left hand side of the queue, this ticket queue, and then process the request ID. So here actually, once you get the request ID, you can store the request metadata like its payload, its different details about the user, the number of seats, all the information payload you can store in some other database. Using the request ID, you can fetch those payload and then process the request, initiating the payment, locking the seat, and all those further processing you can do. So for simplicity, I've just mentioned we printed a console log here processing the request ID, right? So this is about the two functions that we can have in our Redis queue. Okay. Now, in order to process this, what we'll have, as I told, we have to process the request, right? Now, while processing, few things matter actually. Few things becomes important, like how many requests per second my server is able to handle. As I told, let's say we have a single server here, right? But in production, we'll have definitely a large number of server. I'm going to discuss about all these things. But for now, let's assume we have a single server here, which has a capacity of 4 requests per second. It can process 4 requests per second. So that's the maximum capacity it can do. Similarly, that's where we will be mentioning the processing rate here. Okay, let's say my server is able to handle 100 requests per second. That means 100 water droplets or 100 requests I will be extracting from the queue per second. And that's where we have mentioned the interval also. Interval is nothing but the milliseconds where we defined 1000 by processing rate. Okay, it's basically determines the frequency at which you want to fetch the 100 requests from the queue. And here we mentioned the set interval function, which actually, every 1000 by 100, that means every 10 seconds or every 10 millisecond, it will fetch from the queue, process it, and again keep on processing the queue. Every 10 milliseconds, if you process one request, in 1000 millisecond or 1000 seconds, we'll be able to process 100 requests. So that's how we're able to achieve the processing rate using this worker. Okay. Next, we have the main entry point of our application, right? Let's say as soon as our API called /purchase is hit, right? So this is where the user request will come, and first what we want to do, we want to add that request, right? Whatever request data is coming, we first want to fetch how many requests are there, whether my bucket is full or not, whether my key has capacity, whether my queue has capacity to hold new request or not, right? So that's where we first check the length. Okay, whether if queue size is exceeded, the queue max size. So queue max size, let's say 5000 requests at max, right? So at max we'll be holding 5000 requests and processing 100 requests per second. And if any other new request come which is beyond this max size, right, we'll just simply discard the request and send this error, right? Too many requests, try again later. Okay. If the queue has space in it, we'll then add the request ID. Okay. Here we have just simulated some random thing. I mean, request we created a random ID, but here actually you can store the object ID of the request metadata, or you can store the entire request object itself. That's up to you how you want to design it. And then we are just adding the request ID to our queue using the add queue function, which is saw here. Okay. And then we are starting the server. So that's how you see we have implemented a rate limiter using Leaky Bucket algorithm using Redis. So here instead of Redis, you can use Kafka also. That is a better option to handle this kind of large scale application. So that was about the rate limiting and event queue. We learned about event queuing and rate limiting and how we can use this together to control the inflow of requests to our server. Now, why is this important? See, because everything has some capacity, right? A server is a machine also. It has some capacity. Just like if you add excess of water in the bucket, it just overflows. Similarly, our server has some limited capacity. That's why it's quite important to control the inflow of the request to the server so that it can run efficiently and smoothly without getting crashed or without getting overloaded. Okay. However, this is not the only concepts that are used while designing this ticketing platform like BookMyShow, because in practice or in reality, you won't be able to achieve this kind of ticketing booking platforms using a single server like this. As the load increases, we'll want to have something called scalability, right? So let me just give a quick overview of all the other concepts that are required to design this, because I'm not going to discuss everything in detail, because I've created separate videos for all of these concepts. I'll just put them in the eye icon. You can go ahead and watch those one by one. But here I'll just give you a brief how each of these concepts can be utilized here to design a BookMyShow application, right? So first thing is scalability. During peak times, we can use horizontal scaling or auto scaling using cloud-based solutions, right? AWS auto scaling is there, right? In Azure also you can implement it in its own auto scaling, or you can use Kubernetes to add number of worker nodes or worker servers, right, to handle excess load, right, the incoming load based on real-time demand. So we can implement a microservices based architecture. So that means we can split the different functionalities like payment, then ticket booking, ticket locking, then seat booking, all those things. We can divide it into multiple microservices, and we can process an incoming request and communicate with this microservices in an asynchronous or synchronous manner to get the entire transaction done. Second concept is load balancing. Okay. So what we can do, we can use some global load balancers like Amazon Route 53 or Cloudflare to distribute traffic across multiple geographic locations. So that's the job of the global load balancer. Next, we can use application level load balancers like HAProxy or Nginx or Elastic Load Balancer in AWS, right? Which will do what? It will just distribute the incoming traffic, right, or incoming request among multiple instances of our server. Okay. We'll have multiple instances of our server. So you can use application level load balancer to route the request to these worker instances in a even manner, right? So that's how the two global load balancer and application load balancers work. Then we can leverage caching also, right? In caching, what we can do, we can cache frequently accessed data, right? Like the seat information or seat availability, the pricing information, the seat layout. These are frequently accessed information, right? When there is a event going on and people are willing to book for that show or event, we can actually cache this frequently accessed information in some cached server, right? Like Redis. Okay. And obviously you want to have a write through caching mechanism in place so that you can update the cache data in real time, because you want to show which ticket is booked in real time, right? If someone else has booked just now, you want to immediately reflect it in the seat layout to other users. So you want to have a write through caching mechanism. So if you want to understand more about this caching, write through caching, all those things, click on the icon. We will there I have discussed about this in details in a separate video. Okay. Then we can work in terms of database design, right? We can have database sharding, database partitioning. We can do, then we can have multiple read replicas of our main database, right? So when the load increases, let's say millions of people are trying to book ticket for India versus Pakistan World Cup match. So we'll have enough read replicas of our database server so that they can, extract information. Okay, caching is another thing, right? Caching is just extra layer which you are adding, but main thing is database. If you have enough read replica, data will be read from those read replicas. Okay, and then we can have some locking mechanism, right? You can use some pessimistic locking mechanism to lock a given ticket, okay, for a temporary amount of time. So when a user selects a particular ticket, you can actually lock that using some pessimistic locking mechanism, and the seat will be booked for a temporary amount of time. If the payment is not done, we will actually utilize a timeout functions to release the lock from that seat so that it will be available for others also. Okay, you can ensure high availability by having redundant servers, redundant read replicas. Okay, and you having a distributed message queue, high throughput message queue like Kafka, and you can use replication to ensure high availability, right, as you discussed. So all these things are quite important, and you can actually, in order to ensure high availability, you can do implement retry policies, right? Let's say if someone is trying to book a particular ticket, in the background you can retry it, let's say for 2-3 times if the request fail. Okay, so you need to ensure that you have retry policies in your application logic. That's how all these concepts, right, work together to help you design a scalable, highly efficient ticket booking platform like BookMyShow or Paytm Insider or Zomato District. Okay, so our main focus was to show you today how rate limiter actually plays a crucial role in designing this kind of ticketing platforms along with event queues. We saw code examples in Redis and using the Express rate limiter package. So I hope you understood about the rate limiter and event queues in details in this video. If you have any doubts about whatever we discussed, put them in the comment section. I will be sure to answer them. So if you like this video, let's target for 50 likes for this video. Okay, and hit the thumbs up button of this video, and subscribe to my channel. We're targeting to reach 20 to 100 subscribers by the end of this month, so keep supporting. I keep on creating this kind of use case driven system design concepts where it becomes easier to understand system design concepts when you understand it based on a use case, right? A real life use case. You can check out my playlist on system design with real life use cases and system design basic concepts. You'll find all those videos there. And thank you for watching this video, and I'll see you in the next one. Thank you.